கொஞ்சம் பரவாயில்ல. தமிழ்நாடு கொஞ்சம் பரவாயில்ல.
சரி 2 months பேக் நினைக்கிறேன். ரொம்ப
கம்பேர் டு 2 months இப்போ கொஞ்சம் நிறைய ரெடியூஸ் ஆயிருக்கு.
ஓகே. அந்த இம்பாக்ட் வந்து லாங் சஸ்டைனிங் இம்பாக்ட் ஐ திங்க்.
கண்டிப்பா
இன்னும் 6 months ஆகும். எல்லாமே ரிவைவ் ஆகுது. எஸ்பெஷலி இந்த டைம்ல பாஸ் அவுட் ஆகிற ஸ்டூடெண்ட்ஸ் நினைச்சாதான் பாவமா இருக்கு.
கண்டிப்பா ஸ்டூடெண்ட்ஸ் ரொம்ப அஃபெக்ட் ஆகுறாங்க. அவங்க
எஸ்பெஷலி பேச்சுலர்ஸ் படிச்சவங்க பரவாயில்ல, அட்லீஸ்ட் மாஸ்டர்ஸ் படிக்கிறதுக்காக போயிடலாம். மாஸ்டர்ஸ் முடிச்சவங்க என்ன பண்றதுன்னே தெரியாம இருக்கும்.
ஆமா that is very difficult.
இப்போ இங்க யூரோப்ல யுஎஸ்ல இந்தியன் ஸ்டூடெண்ட்ஸ் நிறைய செலவு பண்ணி படிக்க வந்திருப்பாங்க. அவங்களுக்கு முடிஞ்சிச்சு, விசா முடிஞ்சிச்சு, வேலை கிடைக்கல. So it's very challenging. So many people approach me to do something, but yeah, situation சரியில்லைன்னா நிறைய பேருக்கு ஹெல்ப்பும் பண்ண முடியாது.
சார் ஸ்டார்ட் பண்ணிடலாமா சார்?
ஸ்டார்ட் பண்ணிடலாம் சார்.
ஓகே சார், ஆமாம் சார், ரெடி.
So good evening to all. I welcome Mr. Abhiram Durga, who is resource person of the international seminar on technology trends in autonomous cars. So he is one of the alumni of Valliamai Engineering College. He completed bachelor degree in EEE department for the year of 2017. After completing UG degree, he did master degree in electrical engineering in Linnaeus University, Sweden. Now he is doing MBA Strategic Leadership Financing, Blekinge Institute of Technology, Sweden. And he is a development engineer in system and control, Bhavina Cars in India Limited from 2007 to 2010. And he is a simulation specialist and functional project lead for driveline and control Volvo construction equipment in AB. And he is a functional owner, Autonomous Drive Volvo Car Group for the year 2016 to 2019. He is working future lead AD Futures Zenset AB, part of the Volvo from 2019 to present. So he is also founder, product architect, Weber Mobility AB. And his achievement, successful demo of Drive Me project to real world customers of Halo Test Track, received good appreciation from top management. Future technology in video as a spokesperson for plug-in hybrid technology and prototype at VCE in year 2015. Future in Global Technology Magazine of the year 2014 for implementing vehicle simulation models in engine test rigs. This way, the engine can be tested in the laboratory the same way as if it was already installed in vehicle and driven on the test track at VCE. Approval for own advanced engineering project from steering committee of simulation method development for predicting thermal and noise behavior of electric motors and Volvo construction equipment, and a method of development of enabling electric motor in driveline test rig to behavior like diesel engine, saved a lot of costs incurred in prototype testing at VCE. So this is an introduction. And also I welcome to all the participants, faculty from the other colleges, students, So first, I hand over the session to Mr. Abhiram.
Hi, hello dear students and respected faculty members. It's been my pleasure to join this session actually. 13 long years have passed, I graduated from bachelor's. I just can't believe that I could see the same old teachers now. They look the same way actually when I was studying under them actually. So it's good to have you guys in this session. I'll start with the presentation soon. But if you have any questions, feel free to interrupt me anytime. I support any questions. You're always free to ask anything. Just raise your hand or raise your voice. Anything is fine. So I just switched the slide. Okay. I just want to see how many people are. It looks like quite good people. Okay. So currently I'm working on autonomous drive technology located in Sweden for Volvo cars. I have been working in this technology for the past 4 or 5 years now. So I thought this is an interesting topic for the new generation engineers who are studying electrical and electronics engineering to pursue their career in this domain, because this is where a lot of jobs are going to come in future. So yeah, let's take a bit dive into what actually is autonomous car. So we define autonomous car as a vehicle which is capable of doing the tasks like a regular car, but on its own. So to do something on its own, it needs to have a great sense of perception around its environment, what is happening, what it is seeing, where it is seeing, where it is driving, what would be the next action step to do, what is coming behind it, all those things. So to be capable of doing sensing and actuating at the same time, without the input of the human, it's really a big master challenge to solve. So, and it requires like a lot of complex software involved and high-end sensors and high-end hardware from NVIDIA central graphic processing computing units or stuff like that. So yeah, autonomous car is actually called as like unmanned vehicle or driverless car, or sometimes it's also referred as robotaxi. So I'll just present you a short video. Let me know if you hear the video noise or not. So why do we need autonomous car? Why does actually Europe and US is investing a lot in autonomous car technology? We made a short video on this presentation. So I hope this will clear some of the doubts you have. You could hear the voice from the video, right?
No.
Voice not here.
No.
No?
Voice not coming.
This is very sad. Okay, I'll leave this presentation video content with Rajan Babu sir, and feel free to download and see this video yourself. It's not fun to actually see just the video without any audio. Audio is everything in this video actually. So actually, I'll briefly tell why we are investing a lot in autonomous car. So you see in this picture like a parking lot, so many traffic signs, and a lot of less room for the pedestrians to walk around. So if we develop a successful autonomous car, would be no need for this parking spot here and the traffic signs, because they can navigate itself to some other place, park very far from the destination. So it will eliminate the need for the infrastructure needed for traffic signs, road recognition signs, and parking lots. So these parking lots could be translated to public parks or cinema theaters or even residential areas or something. So it will save a lot of, in general, the cities in Europe or US are pretty compact and crowded. So they don't want to afford more space just to leave the vehicles parked when the usability is very low. And fundamentally, the most important reason for accidents is 85% of the cause is human intervention. It's because the driver is careless or less reactive or something. So autonomous cars actually eliminate the accidents because of driver interference or because of driver, the reasons from driver. So that's one of the reasons why the governments or the companies are pushing a lot on investing in this technology, so that they eliminate the main root cause of accidents involved. So basically, the traffic incidents will be very less, and cities become more safer. And also, this combined with electric technology and sharing technology, the need for so many cars would be reduced. So there is like so much background about why so many companies and the governments are investing in an autonomous car. So just briefly describe what is actually the levels involved in an autonomous car. SAE has a standard defined. SAE stands for Society of Automotive Engineering. It's an international standard like ISO, but it's dedicated for automotive engineering guys. So level 0 to level 5 it starts. Level 0 is purely no automation. It is just like a regular car. Everything is done by the driver. So there won't be any assistance or anything from the car itself. So first level could be said as driver assistance, where the driver is fully responsible, but the car will assist in cruising, either in longitudinal or in lateral, mostly longitudinal. So you could say like a cruise control, something like that, where you set a set speed to 50 or 60 kph, and the car will drive in the same speed irrespective of road conditions or whatsoever. But the driver has to monitor all the time, and he's responsible for any sort of accidents or any sort of misbehavior from the car. The car wouldn't take any responsibility. And the same applies for partial automation. This is both controlling the car longitudinally and laterally in the lane. So it tries to keep within the center of the lane which it is driving, and try to reduce the speed or increase the speed according to the lead vehicle it is actually following in the lane. So that's again, driver is responsible. And level 3 is a conditional automation. Driver is needed to be in the car to activate the AD mode, to the mode which the car drives itself, due to legal reasons actually. And but the car itself is capable of driving itself autonomously without any input from the driver. But if some changes happen in the weather or in the traffic conditions, or some sensor fails or something, the driver should be available to immediately take over. So the driver could be relaxed, but he should be quite alert when the time comes for him to take over. The car will request that the driver should take over, something like that. And level 4, which is like a high automation, in this you can you wouldn't be surprised there might not be any steering wheel or brake pedals or accelerator pedals in the car. You just sit in the car and the car drives by itself. You just specify the destination. Say for example, you book a car in the Uber app or Ola app. You put on the destination and the car comes, just picks and drops in the destination without anyone being driving the car actually. This is where actually most companies are investing a lot. Up to level 1, 2, 3, there are some technologies already available both in Europe and United States. There are so many companies which are providing this technologically advanced cars until level 3. At level 4, there isn't anything out in the market yet. It will take some more years for those technology to come out. And level 5 is full automation. It's like I think we will never achieve that, because it says like to drive autonomously all driving functions under all conditions, which is almost impossible, because if it snows or if it's heavily raining, it would be difficult. So this is briefly about what kind of levels are involved in automation in this world. So yeah, I was trying to briefly explain you how actually they work. They should sense what's happening around around the car. So to sense it, it needs a bunch of sensors like radars, primarily cameras, high-end GPS, location accuracy, and LiDAR to some extent in some cars. And you have like, okay, now you sensed everything what around you, but what you should do, you should plan something. So to plan something and decide, and you need some algorithms, advanced control systems, which are based on machine learning approaches or artificial intelligence or something like that. So they interpret the sensory information and then make some planning and control algorithms to send it out to the actuators like a brake actuator, propulsion actuator, steering actuator. What will be the next steps for the car to do? So it will follow the path accordingly as specified by the driver set in the navigation, both longitudinally and laterally. So if it comes any obstacle, it will try to brake for it, and if the scene is cleared, it will try to accelerate and go ahead. So, and autonomous vehicles should have like a high-end GPS as a tracking localization information, which is ultimately important. So it's like a very complex mechanisms, everything happening in real time at a sample rate of 40 hertz, like 25 milliseconds or something. I actually again put a video here which explains very detailed how actually they work. Unfortunately, only I could hear it. So, but this is a short video. It explains about how cameras see and how radar see and how a laser beams spot on. So it is basically the same explanation as what I've explained, but in a video format. So yeah, any questions to anyone so far? Crystal clear, drop dead silence. Nice. I was actually expecting that some questions already now, but okay, good. So to build an automated driving system, I mean, to make a car autonomously drive itself, these are the basic fundamental building blocks. There is no hierarchy among them. Everything is important. First thing, sensing, and then you need to process the data and make a decision making. And then you send the decision making to the vehicle control, which is basically acceleration, steering, braking, to some extent suspension and transmission, but that's very sparse. So sensing would be like you get the raw data from vehicle sensors, radar, camera, LiDAR, GPS maps, and you actually extract the usable information and fuse the data together. So actually you extract the data from individual sensor and make a multi-sensor data by processing them actually. That's a very, very big job where electrical engineers come in action actually. I myself have done a lot of work in sensor fusion algorithms, like fusing the data from camera and radar and sending out as a ray cam data, which is in production now actually. So, and cloud communication is also extremely important, especially cellular connectivity, to understand where the car is and to get the real-time information about what's happening in the car, if there is any accidents involved in the lane it is driving, or if there is some sort of road works happening, things like that, so that the car is better prepared to make a safe stop or something. Okay, and processing and decision making is the place where actually a lot of electrical engineering students work with. Primarily, we develop the decision-making algorithms either in MATLAB or C++, but the underlying principles are like very same. So I think if you carefully plan your career in such a way that you have a great future in these technologies to work. Even in India, there are several companies like Hyundai, Tata, name it like Ola, Uber. They're investing a lot in these technologies, even in India also. So you could expect a lot of jobs coming in this. So I briefly explained you about just in a repetition of the primary sensors which are used. So the first foremost is the radar. I'll tell you more details why radar is used and camera and so on. So let's dig a little deep into the radar. So what does a radar do actually? So basically radar is nothing but radio detection and ranging. So it sends us radio waves. Okay, now it sends out some radio waves and it will have some reflection upon the target it hits and sends it back. So by using some Doppler effect formula, we come to a conclusion that, okay, the vehicle in front of us at this distance is at this distance and it is traveling at this speed. And all this happens at 40 hertz sample rate. So in the blink of an eye, you'll get several times the information about the car ahead of you, the car behind you. Using that information, you will plan accordingly how to steer or how to actually accelerate and brake, trying to keep a safe distance between the front car and the rear car actually. And also radars work in conjunction with IMUs, which are inertial measurement units, we call it. IMUs basically give the yaw rate, pitch, these things of the car which is driving in a AD mode. These things are extremely important for some signal compensation and signal processing and also for correction factors. So, and next comes is cameras. So cameras is like it's there in everywhere. Almost like US has made a law that every car which is produced after 2019 should have a rear camera in it. So basically, by law, almost everywhere in the most of the countries in the world, they're producing a car equipped with camera. So what does a camera do basically? So it's not like just like any other cell phone camera or something. These are like some sort of specialized cameras in automotive application, which will actually give the depth of view. So they are also called as depth cameras or something sometimes. So if you see in the image here, it is able to track the lane markers in the green. That's extremely vital, important information for an autonomous car, so that we'll keep the car in the center of the lane, so we will not deviate. And it will be recognizing what objects are in front of us, whether it is a car or a truck or a pedestrian or a cyclist or a traffic sign. And if it is a traffic sign, what is the speed limit on that? Cameras are extremely important next to radars. So basically combining the data from cameras and radars, we could do most of the longitudinal and lateral control of the vehicle. Majority of it, up to I would say like 70 to 80% of the tasks in dynamic driving conditions. So next is LiDAR. This is a bit more sophisticated in nature. There are no cars out in production which are using LiDARs at the moment because they're really expensive. But there are technologies being developed in LiDARs to reduce the scale, size, and complexity and make it cheaper for them to be installed in the cars. I think LiDAR is similar to radar, but instead of radio waves, we emit laser beams. So laser beams at like we emit like several longitudinally and several laterally, and you get reflections at a much higher rate than a radar. So basically, with a LiDAR, you could see on the picture in the right bottom, where you could actually construct a 3D view or a 3D map sort of you just from the LiDAR data itself. LiDAR is extremely powerful in reconstructing what it has seen. So you could actually reconstruct it if you have seen a road bump or a rock, or it's very powerful. So most of the time we use LiDARs in the test research purposes, so that we install it and we actually see if the new sensors like new radars or cameras are good enough or not by comparing the data with the LiDAR. But yeah, this is still under development to reduce the cost of this and size of this. You see, this is really bulky and it looks very ugly on the top of a car to have such a big device. But yeah, soon you'll have a compact version of this out in the production cars. Okay, ultrasonics are basically sonar technology. They are near field sensing, we call it. They're extremely vital for parking situations. When you want to park a car, then of course, you can rely on LiDAR, but it's much efficient to relay the data from ultrasonics because they're very effective at short ranges from 6 to 10 meters. So depending on and they can actually give you the depth of visibility and everything. The reflections are so good at those short range distances. So you can actually control the car very slowly, very precisely in a small movements, which is a very good application for parking scenarios. So ultrasonics are mainly used for autonomous parking situations. That's the main use case for it. Okay, positioning. So positioning system is basically like a car will have a high definition map and a high definition GPS, and it will continuously monitor where it is out in this map and locate itself within a range of few centimeters. This makes the car to actually understand the traffic it is encountering, where it is driving, because driving in Germany is not the same as driving in Sweden. The speed limits are different, and driving in UK is not the same as driving in rest of the Europe because the different sides of the roads are being driven. UK and India, they drive on the other side, and US and rest of the Europe, they drive on the opposite side. We drive on the right hand side. So all these informations are coming from the map, and using the GPS, it is able to identify itself, localize itself where it is exactly in the world now. And also it's getting a real-time information, cloud communication, that where is the road construction is happening in this road it is following, then it has to plan a new route. Or if there are any accidents in the path it is going to follow, then it has to either make a safe stop or a driver handover or plan a reroute, things like that. Yeah. This is the most important aspect, the software. I think I explained you a bit about why software is so important. So actually the main reason of the software is like they're mostly based on AI algorithms. So every kilometer you drive is being logged, and this data is processed and utilized to find a next level solution and verify that solution and apply that. So the learning algorithm continuously processes the data. It's not only just you riding in your car, but also the fleet of cars, and records the average responses of how average drivers are driving, and it will try to navigate to best possible approach for a given problem. So all this is like Tesla is a master in executing this plan. So if you are driving the Tesla car, how you drive in a different situation is recorded and sent back to the cluster or the cloud. And some engineers, they take the data, analyze it thoroughly, and then they see, like, evaluate if the situation was driven properly or not, or some adaptations has to be made or something. And then they train the machine learning algorithms or the AI algorithms with lots of data to get the reasonable output, and then they deploy it back into the car. So yeah, most of the cars are like connected cars nowadays. You can get over-the-air updates, just like how your Android phone or iOS phone is getting updated. The same way your software in your car gets updated timely. And that's not futuristic, actually. That's available now. So a bit details about the software architecture. So you have all the sensors here, and they give out the base information, and then you extract the useful information. You do sensor fusion, you extract the sign classification and sign detections, and you estimate where the eco vehicle is, and you do localization, and then you send it back to decision making, plus behavior, trajectory planning, and route planning, things like that. And you send it back to the controller, which is again the software module, electronic control unit, which executes everything in real time. And they in turn communicate to vehicle actuators, which is like a brake system, steering system, propulsion system, if there are any others, like power windows or wipers or door openings or things like that. Yeah. A bit more high level of software architecture. They have dedicated names out in the market now for this kind of things. So localization and map building, environment perception and modeling. These are the technical words you often see in research journals and articles. Strategic planning is basically navigation. Tactical planning is basically selecting the lane change maneuvers, everything. Reactive planning, it's basically how you want to drive, how you are driving behind a car. Like you don't want to collide with that car, so you are actually either braking or accelerating by keeping a sufficiently safe distance between your car and the front car and your car and the behind car. So everything is like a high degree of software, which is written in, which is actually running in binary, but which is actually written in MATLAB or C++, and then compiled to binary. So yeah, these are the two important software languages you need to know if you want to pursue your career in this domain. You should be proficient with MATLAB and C++. So just a overview of different automated driving functions which are available already in the market. So if you see the upper bar, it's low velocity, high velocity, and the left side it's structured traffic and unstructured traffic. So low velocity structured traffic is like a traffic jam situation where everyone is driving in their lane. So it's a bit easier to handle. So there are some features which can handle that situation. And highway, it's like a high velocity, but it is a structured environment. It can be handled, but the complexity grows when it becomes unstructured. Parking is extremely complex because it's very hard to recognize who is coming out of the parking lot and who is actually parking, and even it's almost impossible to determine for the car if the vehicle is parked now or not parked, if it's pulling over. It's a very complex scenario to handle, and also the parking space will be like very tight and narrow field of view and too many obstacles like pillars, other things. And urban and rural loads, these are very challenging because there won't be proper lane markers, and there won't be any traffic signs, and the risk of losing a GPS is very high. And also like there won't be any designated pedestrian crossings or some things like that. Anyone can jump in the middle of the road anytime, and there is a high chance of getting like deers or cows into the center of the road in this kind of situations. So the bottom two, unstructured environment, we don't have any solutions yet available in the market now, but that's where most of the research is happening. And most of the features available out are in the upper column or upper row. Yeah, I'm pretty sure you would have seen this kind of slides before. This is just like a reflection upon the SAE levels in a different way. So adaptive cruise control or lane keeping support, you could call it level 1 automation. Integrated cruise assist, which is like it will try to keep you in the center of the lane you are driving and also follow the lead vehicle so that you don't collide with it. So that's integrated cruise assist. This is like highway assist, where you are still needed as a driver to take over in some situations, but the car could plan itself and be in the center of the lane and actually do a lane change after driver confirmation and things like that. And next is highway pilot. highway pilot is like you can relax in the car actually. The car will do everything. And if something bad happens or some sensor failure or some road conditions are like terrible, then the car will automatically pull over to a safe stop. That's actually quite nice. The final level of automation, which is a realistic, it's not a realistic goal according to me, driving everywhere in all conditions, fully autonomous. That's called autopilot. Tesla uses the name autopilot quite a lot, but recently they got banned from National Highway Traffic Security Authority of United States that they shouldn't be using autopilot, which is misleading. They should use only pilot assist. Yeah, just a careful, cautious information you need to know. Okay, what are the major hurdles this technology faces, or this development area has? One is the evolution of technology. We still need a high-end LiDARs at a cheaper price, which is very difficult. A lot of research is going on. We need to have a lot of high-end maps, HD maps available throughout everywhere. And safety is a very big concern. For example, I can tell you what happens if there is a short circuit in the car and some vital electronic control unit is destroyed or damaged and it's not able to compute. So, and the car is not in a position to drive itself, so it requests a driver handover. And if the driver is not attentive or if the driver is not there, it's a very dangerous situation. Who will be liable for that? So this is a very big challenge which as an industry we are facing now, to build a system which is fail-proof. But to build something which is fail-proof, it's the biggest challenge we can ever see. It's just not possible. And government regulations. Every government has its own regulations. For example, until 2016 or 17, Indian government didn't approve the use of radars in the cars. So only after 2017, the ban was uplifted. Volvo was successfully able to sell its cars with features like highway cruising and pilot assist, everything, only after 2017. So every country has its own regulations. I'll talk about this in the last slide I will show you. Policy implications mean about insurance things, which we don't have to worry about. It's a business side, it's not a concern for engineers. And the final question, okay, you are building very ultra sophisticated stuff. You are building a very high-end module system, but who would want to use it? That's a big question. If you're building something top-notch engineered product, and if there is no buyer to buy for it, and if the customer doesn't want it, then you are doomed. But there are really some curious customers who wants to buy this technology. But this whole problem of consumer awareness and if customer wants it or not is solved by a different problem or different approach. When autonomous cars become a reality, it will become more shareable. So the whole definition of personal mobility will change. So you will not own a car, you will just book a ride. That's what happens actually, and that's where actually Europe is trying to go. Reduce the use of cars as personal mobility and turn into more shared mobility. Yeah. I think I talked about this a bit during the beginning of the presentation. The first and foremost reason why we are developing this autonomous cars is to avoid traffic collisions, which are primarily caused by human driver mistakes or errors, and increase roadway capacity. Unfortunately, that video you couldn't hear. I'm so sorry about it. Teams is not so optimal for this kind of PowerPoint presentation, maybe. Yeah, and it's a great relief if you have a car which can drive itself. You just sit and relax, and it is driving by itself to wherever destination you want. That's a really highly appreciated comfort factor, right? So that's one of the reasons, biggest advantages we see. And you could have higher speed limit for autonomous cars because it could have long range radars and long range detection, and the road mobility will be much efficient and faster. And yeah, these are like other car sharing is one of the primary advantage. Yeah, we can jump off to the next slide. Yeah, we didn't really talk about the disadvantages, right? Of course, every technology will have its own pros and cons. When it comes to the major disadvantage, it's like a driver's re-education, because if you have a new autonomous car, it will have a different enabling feature and disabling feature and different control strategy, different human-machine interface, all those things. Just like how you are going for a driver's license, you need to re-educate yourself on how to be able to handle these kind of cars. And once you develop this car, it could be very expensive, that it's not affordable for most of the people or most of the countries. And I didn't really talk about the hacking, cybersecurity. Once your car is connected to the cloud, anything could happen. Cybersecurity is the biggest topic we are trying to invest on nowadays. So how to build a car which is hack proof. It's so nice when you are driving in the car which is hacked and someone drives you to somewhere. So the kidnapping becomes next level. So without even human involving, they can just hijack you anytime. That's the biggest concern for the industry, as it's a big challenge for the industry as well, which a lot of companies together are trying to solve with an open source platform, restrictive environment access, and having an end-to-end encryption protection, things like that. And yeah, of course, loss of jobs. A lot of driving schools, automobile companies not in this technology, transport authorities, taxi drivers, the risk of losing the job is high. But on the other side, it will increase a lot of jobs for engineers actually. So there is always a balance in the ecosystem. Yeah, there is one little risk. They don't completely eliminate the accident. If something malfunctioning system happening in either in the software or in the network, or because of weather conditions, there is definitely a risk of accident. They don't eliminate completely accidents, but they reduce the number of accidents to a lot. And yeah, that's most of it. And let's see what we have got on the next slide. Okay, this is very interesting to see. Who are actually investing in this technology? You'll be surprised to actually see like companies like Apple. Apple is trying to make a car, actually, autonomous car, but they dropped the project. It's called codenamed Titan, but they are actually building the infrastructure needed for supporting this autonomous car. And companies like FedEx, Huawei, of course, everyone knows about Tesla, Audi, Lyft. Volvo is one of the biggest competitor in European market. And you know about Google's Waymo here. There are like 84 plus different companies who are actually trying to invest a lot in this technology. So there are like a lot of jobs coming in this domain, a lot than at an unprecedented level. And this is just an overview of strategic partnerships. Volvo has joint strategic partnerships with both Uber and Waymo. I'll talk a little more details about why these strategies are there and what does it mean actually for the industry. So for example, Mobileye is an Israeli startup company. It was, and Intel bought Mobileye, and they were in a collaboration with BMW. Lyft is in a US-based company developing the systems for self-driving technology. It's in a collaboration with Ford and GMO. And Waymo is another big company owned by Google, which is in collaboration with Volvo Cars and Fiat Chrysler. So this is the reason why they're actually partnering. both Waymo, Lyft, Uber, they don't want to develop a car. They want to develop a technology which can enable any car to a self-driving car. So for that, they need to partner with a automobile manufacturers who will produce the base car, which will have the hardware needed, which will support the redundant safe stop braking and steering actuators and all those things according to the requirements set by the companies like Lyft and Uber. So what actually Uber and Lyft is trying to do, they will have like something called as SDS, self-driving system, which will have a lidar, cameras, radars, ultrasonics, and they'll also have their own high-end NVIDIA graphics processor, and they will have their own software, their own connectivity, everything. So they just want to mount their system and turn any regular car to an autonomous car and use it as a shared or ride-hailing service in their fleet. So Uber and Lyft that's the aim for them. And Apple is on the other side. It wants to develop chipsets, or it wants to develop the technology infrastructure needed for this, just like Intel and NVIDIA is doing. Even Google is trying to do. And Apple wants to do very similar to iOS App Store. For example, Google has launched Google Android Auto. You would have seen that images. I don't know if you know about it. But just like how Android platform for mobile smartphones, it has launched a Android platform for automobile. And Apple is also trying to do the same. Yeah. Okay, now it's interesting actually. We talked a lot about this technology, and we haven't really talked about where this could be useful the most. You could see this like this is the index prepared from a European company, Gravy. So the countries, according to the index, which company is standing out in adopting this technology. Basically, it supports the people mindset, the infrastructure around it, like the sophisticated lanes and what do you call this, traffic sign informations, everything. You need a proper surround infrastructure for an autonomous car to successfully execute its task. So you have Netherlands and Singapore in the top, US and Sweden almost in second place. So the list goes like this. Yeah, I think I'm mostly done with my presentation. So yeah, in conclusion, I could say that this is a disruptive technology for this whole automotive industry. This is something like over the past 100, automotive is like 100 years old companies, basically 100 years old industry. And for the first time, something really tremendously technically advancement is happening in this industry. So I think you would find a lot of jobs, interesting jobs in this. As I said, if you are well prepared, do plan your thesis in such a way that you do something around this, either in signal processing or working with the sensors, sensor fusion, or control algorithms or decision making. You have so many areas to play around. So, but try to do either in simulation in MATLAB and learn improve your skills in MATLAB and C++. And I'm very sure that you'll find a job in this domain, because this is by far the highest growing domain. Okay, thank you. And if you have any questions and comments, yeah, please feel free to ask. You're very silent, guys. If I were you, I would have asked so many questions.
Students, if you want to ask any question, ask me.
I couldn't hear you.
Hello.
Yeah.
Sir.
Yes, Karthik.
சார் எனக்கு ஒரு டவுட். இப்போ எலக்ட்ரிக் வெஹிக்கல்ஸ்ல மிக ஃபியூச்சர் இருக்குன்னு சொல்றாங்கல்ல சார், 2020 30 அதுல அட்டானமஸ் கார் வரதுக்கு நிறைய பாசிபிலிட்டிஸ் இருக்குல்ல சார்?
Yeah.
டீசல் அந்த இதை விட எலக்ட்ரிக் கார்ஸ்ல கண்டிப்பா நம்ம ப்ராசஸிங் யூனிட்ஸ் நிறைய யூஸ் பண்ணுவோம்னால இன்னும் ஈஸியா இருக்கும்ல சார் ஆட்டோனமஸ் கார்லாம் டெவலப் பண்ணதுக்கு.
Actually, by far, electric vehicles are very simple. Before in autonomous vehicles, I was in electromobility, working on electric cars. The complexity of electric car is a lot less. You basically have battery, electric motor, and a power electronic module controlling that, and very simplistic. So almost major automotive companies are actually developing electric autonomous cars. And also, if you see the other side, by far, so far, how automotive companies are surviving is not because of selling the car, but because they were able to sell the spare parts on engines, brake oil, gaskets, blah 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 blah. That was the highest revenue. And once the cars are electric, virtually there is nothing indestructible in an electric motor except for batteries, which will be covered by lease cost or something. So the automotive companies will suffer a lot in their aftermarket on sales and spare parts sales, everything. So to encounter that, they're investing on autonomous drive technology. So they want to sell as subscription models to the consumers, and that's the only way they can survive in their business. It's actually a good question you asked that.
Students, other questions? If you want to ask any questions, ask. So anybody want to ask question? So okay.
Okay, guys, thank you. It was a nice connecting with you all virtually. Stay safe, stay home. I don't know if still that rule applies, but stay really safe. And you can reach me on LinkedIn anytime. I'll be open to help you out on any questions you have. If you have any questions with your bachelor thesis or anything, just try to contact me. And thank you so much, sir, for giving this opportunity.
Definitely. So I thanks Mr. Abhiram Durga to give wonderful presentation about technology trends in autonomous cars. It is very useful for students, faculty, and research students. I thank our management, principal, vice principal, and HOD to give the opportunity to conduct the international seminar with great success. Okay. So உங்க presentation இது பண்ணிடுங்க, ஆஃப் பண்ணிடுங்க. So we take one photograph with you.
Yes, sir. Sure.
ஸோ மற்றவங்க கொஞ்சம் அவங்களுடைய இது ஆன் பண்ணிங்க வீடியோ இது. One minute. ஸோ தேங்க்ஸ் அபிராம் சார்.
ஓகே சார்.
சார் முடிச்சிடலாம் சார்.
தேங்க்யூ அபிராம்.
ஓகே சார், கண்டிப்பா வில் மீட் அகைன். தேங்க்ஸ் ஸ்டூடெண்ட்ஸ், தேங்க்ஸ் ஃபார் லிசனிங்.
நெக்ஸ்ட் வீக் எஸ்ஆர்எம் அவங்களுக்கு இன்டர்வியூ கண்டக்ட் பண்றாங்க சார். நெக்ஸ்ட் வீக் அவங்க இன்டர்வியூ
I'm trying to establish a collaboration between Fab Lab and my own company. So we are negotiating some things with them to hire student interns who can work for me.
Super. Very good.
Thank you, sir. Okay, sir. I'll see you.
So,
Bye. Have a nice weekend.
so okay. So I send feedback link your mail ID. Okay. So after that you receive all
Okay,
of
sir.
them, your certificates. Okay.
Okay, sir.
Okay, Abhiram. Thank you, Abhiram. Okay.
Okay, sir. Bye.
Bye. Bye.
Bye, sir.
Okay.